Hello, hello. All right, welcome back. So in this one, we're going to continue talking about solving systems of linear inequalities. And there's a nice little foldable that some of you can easily download off the internet, and or you already received it in my class. So I'm going to talk about filling this out real quick. And let me change my colors. I'm going to go with pink because that is my personal favorite color. And I'm going to go ahead and just do a no fill here. All right. So I'm going to talk about the boundary line. All right. When I talk about a boundary line, if my symbol is less than, so my symbol is less than or my symbol is greater than, then my line should be dashed, or I can say dotted. So I'm going to say dashed or dotted. Either one is acceptable. Then if my line is greater than, less than or equal to, it has that little line underneath, or greater than or equal to, I should have a solid line. And that means that anything that lies on that line, on this line here, will be a solution for that inequality. When it's dashed, anything that lies on that dashed line will not be a solution for that inequality. Another way to remember the difference between the two, to remember whether or not you have a solid or a dashed line, is to remember that a solid line will have that little line underneath. If it doesn't have that line underneath, just remember you need to dash it. Now shading. If it's less than or equal to, we're going to shade below. And if it's greater than or equal to, we're going to shade above our boundary. Shade below our boundary, and that's the boundary line. Now again, another way to remember is to test the coordinate. I'm spelling that wrong. To test the coordinate point, and I'm just going to use abbreviation 0, 0. Now the only time you can't use the coordinate point 0, 0 is if our coordinate point, our graph, our boundary line is going through the origin. Now I'm going to go through down to look at this one here. So when we're talking about linear systems of linear inequalities, we're looking for what are the solutions, okay? Well, everything, if we look here, everything in this region here is a solution to this line here, okay? But in terms of this region here, this is a solution we know for this dotted line here. But where they both overlap, again, so we can see right here, both of the shaded regions overlap each other. So here are all of the solutions to this inequality and this system of inequality. So any point lying within this double shaded region where the shaded regions overlap, I can even do in the half. It doesn't have to be a pretty point. Now, anything lying along this dotted line, except for right there where they intercept, will not be a solution, okay? Because that is a dashed line. And then anything along this region here, including where they intersect, will also still be a solution because that still lies in the shaded region. And we know that this point here, this line, is a solid line, and we can have solutions to that, all right? Now I'm going to talk about example 1. All right, example 1, we have two inequalities. I'm going to go ahead and I need to rewrite this inequality. I have 3y greater than or equal to x plus 6. I need to make it to where it is y equals. I need to have it in slope-intercept form. So in order for me to isolate the y, I'm going to divide by 3. I need to divide each term by 3. So then that becomes 1. So 1 times y, we just leave it to be y. Y is greater than or equal to, don't forget our equal to symbol. Now I can say I have x over 3. That is the same thing as saying 1/3 x. I want to write 1/3 x so that I know what my rise over my run is. My rise is going to be 1. I'm going to rise up along the y-axis 1 unit, and then I'm going to run along my x-axis. I'm going to run 3. Now 6 divided by 3 gives us 2. Okay, now I'm going to go ahead and graph it. So I'm going to go to positive 2 right here on my graph. And I'm going to go up 1 and then 1, 2, 3. Up 1, 1, 2, 3. And then I'm going to go down 1, 1, 2, 3. Down 1, 1, 2, 3. All right, now my line is going to be solid because I have this equal to symbol there underneath. So I'm going to draw my line. Can't forget my arrows. Now I'm going to talk about, we'll go purple for the next one. I'm going to talk about the second equation. So this one is 2x plus y is greater than, or not equal to, just greater than, -5. I need to just subtract x. Subtract x from 2x from both sides. So that becomes 0. I'm left with y is greater than -2x minus 5. I'm going to do, let's see, just so that it's a little bit more visible, I'm going to use a lighter color here. I'm going to use purple. So I'm going to go to -5 on the graph. So I'm going to start from 0, 0, 1, 2, 3, 4, 5. So that's going to be right there. And if I go down, because it says I'm -2, so my slope is -2 over 1. Well, if I go down 2 units, I'm kind of out of room on my graph. I could go down 2 units and write 1 and graph it. Yeah, I can do that. But I'm kind of out of room there. So now, just like I would do on a normal graph, since I'm out of room, I'm going to go back the other way. I'm going to go back where I began, and I'm going to go to the opposite direction. Okay? So I'm going to go up 2. Normally we go to the right. But since we're going the opposite direction that we should be, we're going to go to the left. So I'm going to go up 2 units and to the left, up 2 units and to the left, up 2 units to the left, up 2 units and to the left. Now, I want to talk about this real quick. If I were talking about it in terms of a system of equations, we would have our solution right here, where they intersect. But we're not talking about a system of equations. We're talking about a system of inequalities. So that changes things. And I did forget to shade my line first. So I need to go back and shade it. All right, we'll do that. So I'm going to shade for the first one. I'm going to shade above. And the reason I know that I'm going to shade to above is my graph is going to the right. Another way that you can remember, again, is we can test the coordinate point 0, 0. So 0 is not greater than or equal to 2, so that I know that that coordinate point 0, 0 should not be shaded. So it's false. Okay, 0, 0 is not true for that inequality. We're talking about the red one, so this is our inequality. Let me write it here. I'm just going to do an arrow right there. So that is the inequality there. My arrow disappeared. All right, now I'm going to shade, and my shading disappeared too. Technical difficulties. Okay, now do a different color. I'm going to do yellow, and I'm going to shade the right one, the bottom one. The bottom one, again, is also to the right or above. Now, again, it gets a little confusing on where I should shade. So let's talk about that again. I have the coordinate point 0, 0. 0 is greater than or equal to -5. This is true. So in terms of this inequality, which is there, it is true, so I need to shade that region. Now, the only solutions to the system is here in this region that is shaded. Let me see if I can get a little bit better color there, where I just shaded. Now I want to look at these ordered pairs. I want to see if these ordered pairs that I'm given at the bottom, if they are a solution to the system. So I'm going to check -5. So I'm going to go 1, 2, 3, 4, 5, and 1. No, that is not a solution to the system of inequalities. That's a solution only to this this line. Actually, not even that line. It's a solution to the y greater than or equal to 1/3 x plus 2. Okay. Now let's look at -2. We have -2, 1, 2. And then we have 1, 2, 3, 4. That is a solution to our system of inequalities because it's in that region where the shades overlap. Now I'm going to check 3. So I go 1, 2, 3, and then up 1, 2, 3. That's that point right there. That is also a solution. It falls in the shaded region, and it's on a dot on the solid line, so therefore we know it's a solution. Now I'm going to check 2, -1. 2, -1 is obviously not a solution. Now let's check number where we have 4, 3, the coordinate point for negative 4, 3. So I'm going to go 1, 2, 4, 1, 2, 3. Okay, that's that coordinate point right there. That is also not a solution. Yes, it falls in the shaded region, but it's on the boundary line that is dotted, so it is not a solution. So the only two solutions for this system are negative 2, 4, and 3, 3, at least in terms. There's more solutions to the system, but in terms of whether or not the solution choices that are given are a solution. All right, I will see you in the next video where I will go over example number 2.